Good morning, everybody. It's Friday. We've almost made it through an entire week of e-learning, and I got to be honest, you guys are killing it. I was a little worried to see if you're going to be able to hang in there and do all this, but I'm a little afraid that maybe you like it better than being in class with me now. But anyhow, I really appreciate that you guys are taking this seriously. So today is our last lesson of this week, and then we're going on spring break for a week, and then we come back and we're going to dive back into it. So I know Governor Pritzker has said that I can't grade you on anything that's going to hurt your grade. That's not really a big deal because most of you guys have been doing all the work, so it's just been helping your grade this whole week. We do need to take some kind of test or quiz, and we'll do that when we get back from um, spring break, I suppose. So let's just keep moving forward, and then we'll come back. We'll have something fun to talk about when we get back from all this stuff next week. So here's where we left off yesterday. We were talking about equivalent resistance. If you have, well, let's go back up a little bit. If you have a couple that are in series together, you just add them up. No big deal. And the real difference between series and parallel resistor circuits is that series circuits, there's just one path. If the current has to get from here to there, the only way it can do is go through all of the different resistors one by one. What that means is that the current is the same all the way through. That's really interesting. So let's just do a couple notes here on this, just to remind us of where we are. All right, so series versus parallel. In series, there's only one path only. And what you find is that the current is the same everywhere in that path. Well, what happens to the voltage then? Well, the voltage drops little by little. Each resistor takes a little bit more voltage. So the voltage drops little by little in a series circuit until all of it is gone after the last resistor. So we've been talking about that. If you're not sure what I mean by that, you can go back and do some practice on that. In parallel, things are a little bit different. And in this case, the voltage is the same across each path. Remember, the significant difference between series and parallel is parallel will have multiple paths. You can have something like the current can go 3 different ways or 2 different ways, no matter how many different paths. So that means more current gets to flow because it has 3 different ways to go. So the current might be different at each one, depending on the resistor. But what you got to know then is that the currents in each path will add up to the total current through the circuit. And what that means is that if you have like 2 amps going through this path, and 2 amps through this path, and 2 amps through that path, it means there's going to be 6 amps going through here, and then these 2 and 2 will add up again and become 6 again there. Or through here it would be, 2 plus 2 would be 4, and then plus another 2 would be 6 here. So anyhow, that's a lot of numbers getting thrown at you really quickly. What you guys need is practice, and of course there is practice. Today, what you're going to be asked to do, I don't know when I'll make these due, maybe on Tuesday after spring break to give you some time to poke around with them, but you got to have something to do over vacation, right? I can't see vacation being too terribly different than what's been happening right now. So let's check it out. Here we are in series circuits. This is, I'm just going to go to a 2 resistor circuit and show you what you got to do. Okay, so here's where we are with this thing. All right, here's your battery, and then it's going to push current through this. So we know that no matter what's happening in A, it's got to be the same in B and C because there's only one path, so the current is the same. So the way we figure this out is the easiest thing is to add the resistances because in a series circuit, they just add up. So if it's 1.5 here and 1.5 there, the total current, or I'm sorry, the total resistance in the circuit should be 3. So then to find the current at position A, it would be the total voltage divided by the total resistance, which would be 2 amps. Oops, don't want to do that. Into that. And this would be 2 amps. Now the cool thing about series is then that it's going to be 2 amps there and 2 amps there because the current is the same at every place in a series circuit. All right, and we can keep going like this. I'm not going to do the whole thing for you, but I'll show you. Well, wait a minute. How do you do? The key here is to either get the total resistance together or something else. So let's pick this one down here, letter D. Hey, I don't know what the total resistance is because I don't know the resistance of resistor 1. How am I supposed to figure that out? Well, the current at C is 1.5 amps, so that means the current at B must also be 1.5 amps. Give me that. What's going on here? Point 5, enter. This is okay. This is 15. That's not what I want. 1 point. Okay, skip that one. Okay, let's do this one. I can get that decimal to go. If the total resistance is 1.5 amps, I could either get the current through here or I can get resistor 2 because resistor 1 is 0.5 amps and the total resistance is 1.5, so resistor 2 has to be 1 amp. So 1 plus 1.5 would be that, or 1 plus 0.5 will be 1.5. So then you can say, okay, well 6 divided by 1.5 is going to give us 4 amps. So, and that's got to be the same at all different places, 4 amps, 4 amps. And you can keep going and fill this whole chart up. So that's what's going to happen for this series circuit. It's a little bit of puzzle solving, but I think you can do it. Now let's talk about what happens in the parallel. That's going to be a little bit more tricky. All right, and I'm going to go right to the master level because it has 2 resistors to get parallel. So let's take a look here. All right, this is a little bit weirder. Let's see if I can bring this page where we can see it. Thank you. All right, this is a little bit weirder because now you have 2 in parallel. So whatever voltage I have coming out of here, it's 2 paths it can go through. That makes it easier. So what do I know about this? Well, I know the total battery voltage is 12 volts, and I know resistor 1 is 2 ohms. So the current through there is going to be V over R. So 12 divided by 2. The current through, wait a minute. The current through, at A is 9 amps total. So check it out. The current through this one, if it has 2 ohms of resistance and 12 volts across it, would give us 6 amps. Now, resistor C over here, or resistor 2 rather, is 4 amps. So it's 12 volts across a 4 ohm resistor. That would be 3 amps, because 12 divided by 4 will give us 3. So check it out. If you have 6 amps here and 3 amps flowing through there, the two of them are going to add up to be 9 amps. The same thing at position A. So let's do another one. Something that's a little bit different. Let's go down and do this guy at the bottom. If it's 48 volts, ooh, that's a lot of voltage. Resistor 1 is 6 ohms. What would be the current through there? 48 divided by 6 would give us how many amps through resistor 1? And that's at B there through this path. So 48 divided by 6 is going to be 8. All right. And then we know through here there's 12 amps flowing. So what's the total amount of current flowing when these 8 amps come flowing and there's 12 amps come flowing out of there? That's right. It's going to be 20. But wait a minute. What is it at position A? How many amps must be flowing out of this to get split between these? Well, it also has to be 20. And what that means is this battery is pushing out with a force of 48 volts but there's a total resistance of these two resistors is fairly low. We're going to figure that out in a minute. So you end up with 20 amps of current flowing out, getting split up between 8 here and 12 amps there, and then they join back together, become 20 again. So the last piece of information, we need to figure out what's the resistance of this. Well, we know the voltage. What's the voltage drop across this resistor? 48 volts, because remember, it's all 48. If we were to color this, it'd be red, 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 all the way on top, blue, blue, blue on the bottom. So it's going from 48 to 0 here. And there are how many amps flowing? 12. So it's 48 divided by 12. That's right. It's 4. And there will be 4 amps flowing through there. Now check it out. Or I'm sorry, that would have a resistance of 4 ohms, which would provide for that 12 amps flowing through there. All right, I think I've covered this. I don't want to lecture too much. I think you guys are getting it. You just have to get in there and poke around. You remember your laws. If you get confused, go back to your notes or these notes. They'll, I don't know if you want, I can try and share them with you a little bit. Come on now. I'll show you can't do anything. All right, never mind. All right, miss you guys. Hope you're doing well. Have happy spring break. Later.